So today we are gonna do a question which is quite simple actually. So it's convert 1 Newton into dyne. So here both Newton and dyne are actually derived units. It's just a special way to call them. So if you were to do this, if you didn't know how we are actually doing it, so some people can actually do this as well. So I will show it in the end, but let's see how it works. Never mind, let's see how normal people would do it. If I was a normal person, I would write this as 1 Newton, and in normal calculation I would still do it this way. So 1 Newton is, Newton is the unit of force. So in SI system, because Newton is the SI unit of force, I can write this as kilogram meter per second square, because m into a, m gives us kg, a gives us meter per second square. So Newton is equivalent to kg per meter square, a kg meter per second square, and dyne is the Celsius unit. So Celsius meaning centimeter, gram and second. So we can do 1 kilogram, and kilogram will be converted to 1000 grams. Then we can write meter to centimeter, that's 100 centimeter, and second will stay the same, which means it will give us 10 to the power 5. So let's move this a little bit to the left and up. So 10 to the power 5 gram per centimeter per second square. Gram centimeter per second square. So this means 1 Newton equals to 10 to the power 5 dyne. So if you were a normal person, you will do it like this. But the question comes, why are you doing it like this? You don't understand why you are doing it like this. Why you can convert the kilogram into a gram so easily. That's what we are gonna talk about. What's actually happening. So let's try to solve this question. So the given physical quantity is force. The dimensional formula of force is mlt minus 2. So now comparing it with m to the power a, l to the power b, t to the power c, we get a is equals to 1, b is equals to 1, and c is equals to 2. So what we are gonna do is let 1 Newton equals to n dyne. So n is a number that we are supposing. We don't know the number, so we are just supposing it as n. So now we have to solve it. So how I'm gonna do it is, let's do it in the next space, because I don't think we have space, or I can do this. Wait, let's move this back down here. Boom. Okay, and then I can move this to the top. Then we can continue from here. So right here we have the MKS system, because MKS or SI system, because they are very similar, so I can write any of both are used. They are basically the same. So in MKS system, let's suppose M1 would be in kg, and it would be 1 kg, and here in L1 will be 1 meter, T1 will be 1 second, and N1 will be 1. It's not that necessary to write 1, but we are just writing it to be sure. So here m2 is 1 gram, L2 is 1 centimeter, T2 is 1 second, and N2 is N. So if you watched my previous video, you will see the formula. The formula is not that necessary actually, but we are gonna use the formula and see how to do it. Then we have N2 equals to N1, M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C, and let's add the brackets. So here's the first one bracket, the first bracket, and the second bracket, and finally the third bracket. So now let's put the values. So putting the values, we will get N will be 1 because it's 1 Newton, so 1, and here is 1 kg by divided by 1 gram to the power 1. Similarly, 1 meter by 1 centimeter to the power 1. 1 second to the power divided by 1 second to the power minus 2. Let's add the brackets. Let's add the brackets. I think I made one more extra, so remove this. So now, since kilogram and gram is not the same thing, right? It's not the same thing, so we have to convert kilogram into gram. So how we are going to do it is 1,000 gram divided by 1 gram to the power 1. Similarly, 100 centimeter divided by 1 centimeter, 1 second. So it's really hard to say something when you're doing calculations. I mean, I'm trying to make it interesting, but I don't have anything. So just see. I don't know what to say, but I really do not like this method. It's like you're just remembering the formula and you're just doing it. I like the other way, which I will teach you after this. So as you can see, the gram and gram are same, so we can cancel the grams. Centimeter also the same, second also the same, so they can be cancelled. So now we can calculate. So in the next page we have N2 is equals to 1 times 1,000 times 100 times 1. That would leave N2 to be this, which is actually 10 to the power 5. So now we know that N, since N2 is N, it is also 10 to the power 5. Therefore 1 Newton must be equals to 10 to the power 5 dyne. So dimensionally we found it. So because this is the dimensional method to convert units, but there is also another way that is very easy, more easier than this method, and works just as well. So let me show it to you. Here 1 Newton, it's basically like this method, but I'm actually gonna explain how it works. 1 Newton can be written as 1 kilogram meter per second square because it's equivalent. It's basically the same thing. So now let's write it as this. So 1 meter, 1 into 1 kilogram into 1 meter into 1 second minus 2. Yeah, we can write it as this. It would be the same. So now what we can do is 1 into 1 kilogram times 1 kilogram by 1 kilogram. You might think, why are we doing this? We are doing this because dividing and multiplying by the same thing does not change the result. So, and now you will quickly see how this works out. So 1 meter times 1 meter by 1 meter into 1 second minus 2. So now to convert, we can do 1 kilogram times 1 kilogram is written as 1000 grams, and we did it in the top part because we have to cancel the kgs. We don't want the kg when we are done with the calculation. So 1 kg over here. Now the kg will cancel out. So if we had gram in the bottom, it will not cancel out. That's why we are putting gram in the top. So again, into 1 meter times 100 centimeter by 1 meter into 1 second per. So here meter again cancels out, so we have gram centimeter per second square. So this is how you can do it like this. You can directly convert it kilogram to 1000 grams. This is what is happening. I find this very cool. This is, I don't find it insane. It's like a very logical explanation to why it happens. And 10 to the power 5 dyne, because these units are basically dyne. They can be written as dyne. So in the next video, we are gonna do another question about this, and stay tuned.